Hello, my name is Gary Entler, Project Director for Ophthalmic Training and Certification at the MS Corporation. Along with my colleagues Don and Lisa, I will be demonstrating the modified ETDRS technique for refraction to obtain a best corrected visual acuity. In most studies, refraction is done at a 4-meter distance from the chart. Refractions are always done using ETDRS chart R, and we always begin by refracting the right eye first. If a patient wears contact lenses, they must be removed at least 1/2 hour before the refraction. The starting point for the refraction can be determined in a number of ways. They include using a lensometer to determine the patient's current eyeglass prescription, retinoscopy, automated refraction, using a refraction obtained at an earlier visit, and beginning at plano, provided the patient's uncorrected visual acuity is at least 2100. There are 3 basic components to refraction according to the ETDRS protocol. They are determining spherical power, determining the cylindrical axis, determining the cylindrical power. To start, let's take a look at how we determine spherical power.
I'm going to place this on your face. All right, I'd like you to look at that chart. Please read for me the smallest line of letters that you can see clearly.
HVZDS, NCV, K, O, and that's it.
Our examiner will first have you look through a plus 0.50 diopter sphere.
Looking at that last line you just read, I'm going to show you a lens, and I want you to tell me if this lens helps you see better, worse, or no different.
That's worse.
This is worse.
The next lens the examiner presents will be a minus 0.37 diopter sphere.
And is this better, worse, or no different?
Better.
If the patient prefers minus spherical power, additional minus is presented in 1/4 diopter increments. Because this protocol is designed to push plus, myopic patients must earn additional minus spherical power by reading at least 1 letter on the next lowest line of the chart.
And can you read anything underneath that line?
CZS something N,
Anything else?
something NV,
Now, is this better, worse, or no different?
better.
Better. Can you read anything below the line you just read?
Mm-hmm.
Can you read it, please?
KDNRO, ZRCSY, DVONO.
Okay. Now, looking at the last line that you just read, is this better, worse, or no different?
That's better.
Okay, can you read the next lowest line?
KONRS,
Okay, anything underneath that line?
OHV, OK, NZ, OKO.
This patient continues to accept additional minus sphere power and now has a total spherical power of minus 3.00. Once the highest plus or least minus sphere power is determined, the patient should be asked to read the smallest line possible. A minus 0.37 sphere is held in front of the trial frame and the subject is asked if their vision is improved. If it is not, The plus 0.50 sphere is tried again to see if the subject will accept more plus. If the patient's vision can no longer be improved with additional minus or plus spherical power, then we are ready to begin the second component of the ETDRS refraction protocol, determination of the cylinder axis. For purposes of this discussion, only plus cylindrical techniques will be presented. If the beginning approximate refraction contains a cylindrical correction, changes in cylindrical axis are tested by adding a 0.25, 0.37, or 0.50 diopter cross cylinder. First with the positive axis 45 degrees to one side of the cylindrical axis, and then with the positive axis 45 degrees to the opposite side of the cylindrical axis. If there is cylinder present, begin to check cylinder axis first by toggling 45 degrees on each side of the axis.
Okay. I'd like you to read the smallest line of letters that you can see.
ZHCSR.
Anything underneath that?
Not really.
Okay, I'd like you to go to the line above the one you just read and focus on the circular letter. And I'm going to show you two lenses, and I want you to tell me which lens produces less blur. Okay? Which is better, 1 or 2?
2.
2. And 1 or 2?
1.
1 or 2?
2.
If the patient can't choose between the two, move the original axis setting 5 to 15 degrees in each direction and repeat the testing with the cross cylinder to confirm the original axis is correct. If one position is preferred, move 5 to 15 degrees to the positive axis and repeat until the patient is unable to decide if one position is better than the other, equally blurred.
Now, focusing on that same round letter, is this better, 1 or 2?
1.
1 or 2?
2.
2. 1 or 2?
No difference.
No difference. Okay.
Once the cylindrical axis has been determined, we are now ready to test cylindrical power.
Focusing on that round letter, is this better, 1 or 2?
2.
2.
Add or remove lenses in quarter diopter increments until the patient indicates that both choices are equally blurred.
And again, is this better, 1 or 2?
No difference.
No difference.
For every 1 diopter added to the cylindrical power, the examiner must compensate for the effect on the sphere by adding a half diopter of minus spherical power. Then, for every additional half diopter, add a quarter diopter minus lens to the sphere, again in the opposite direction. If the beginning refraction is only spherical, test for astigmatism by arbitrarily placing a quarter diopter cylinder at 180 degrees and ask the patient to compare this with a quarter diopter cylinder at the 90 degree axis. After choosing the better of these two, then refine the axis and power as previously demonstrated. The cylinder examination is complete when neither power nor axis can be improved, equally blurry with the cross cylinder in all directions. Recheck the sphere with plus 0.37 and minus 0.37 and change in quarter diopter increments. If the sphere changes, recheck the cylinder until no further significant changes are made.
Can you read the next lowest line?
NOKHD ZH.
If a subjective refraction is not possible at 4 meters, in one or both eyes. Attempt to refract at 1 meter.
Better, worse, or no different?
If this is successful, when recording, subtract plus 0.75 from the final distance refraction. If a refraction cannot be performed at 4 or 1 meters, then the distance subjective refraction obtained at the most recent earlier visit should be used for measuring visual acuity. Or, if this is the first visit, use data from retinoscopy, autorefraction, or the patient's current glasses. Once all 3 steps of the refraction have been completed and the patient's vision improved as much as possible, the examiner should again attempt to refine the spherical power by again presenting both a plus 0.50 diopter lens and a minus 0.37 diopter lens. When no further improvements can be made, the refraction is complete. The refraction should be used when assessing best corrected visual acuity.